Let's take a look at Leet code question 200, number of islands. And this is a really popular interview question and will help us understand some graph questions. So let's dive into this. Given an m by n 2D binary grid, which represents a map of ones, which is referring to land, and that's a string one, and the string zeros, which is water, return the number of islands. So an island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically, so not diagonally. You may assume all four edges of the grid are surrounded by water. So basically, if you look at this example here, you see that one is land. So if you look at all these connected ones here, so here, 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 and this one is also connected to this one here, you got one sort of chunk of land here. And if you look at this example 2, we see that in here we've got the square 2 by 2 full of ones, which represents land. And then you've got this one here, but that's diagonal to that. So that's considered its own bit of land here. And then you got these two adjacent cells here in the grid. So you got 3 islands there. So to be able to solve this question, we essentially need to do either depth first search or breadth first search to sort of continually go through it. So I'm going to solve this using depth first search, and essentially what we need to do is we need to sort of loop through our rows in our columns. So that's going to be a double for loop, or of n squared there, and we want to essentially, we need a way to be able to track if we've already been to a cell before. So essentially, we want to say, well, if the cell is equal to the string 1, that's going to represent an island. So, we want to increment the island if we haven't sort of traversed through that area before. So we got 1s for the land and 0s for the water. And we could, like, the number in the cells sort of could be whatever, but we may as well have the number 2 because it's the next sort of logical number there to represent if we've sort of hit a bit of land there. That, if we've got land and we've been there, we can just sort of mark it. So that way we don't need to keep recalculating if we've been there. And that way we're able to expand out, and we're going to do that with depth first search to be able to determine if adjacent elements are pieces of land or not. So we'll have the total number of islands here. This is a really fun question, actually. It's probably one of my favorite ones. So essentially what we want to do is, and we'll just do a little bit of validation here. If the grid has a length of 0, we can simply return 0 because there is no islands, because there's no data. So we want a way to be able to track the number of islands. So let's just have this variable here, and we'll set that to 0 because it's initially going to be 0. And then what we want to do is we want to have a for loop, and we're going to increment for all the rows. So we'll let I equal 0, and that needs to be less than the grid's length. And then we just go ahead and increment. So that's just the standard for loop here. And then I'm just going to go ahead and copy that because we need to go through all the columns as well. So I'm just going to change the I to a J. And basically, rather than the grid, we can just go ahead and we can take grid 0's length. So that's just any 1 rows. They're going to represent all of the columns, and they're all going to be the same. because it's n by n. So that will get us the length of the columns. And then what we can do is, essentially what we can do here is we can just say, well, if the grid in the cell for the row and the column that we're iterating through, if that's going to be equal to 1, well, then we know that that's going to be an island. So we can just say, we can call number of islands, and then we can just increment that. Now that's, you would think would increment too many. However, we're going to have this sort of recursive depth first search call here. So we're going to call traverse land. And we're just going to pass in the grid and the I and the J value here. Because they'll increment the number of islands, yes, but then we're going to have this recursive function that's sort of going to loop through and then mark bits of land as seen if it's a bit of land. So we'll change the number to 2, and then, you know, once it hits its exit condition, we would have already traversed and changed the numbers in the grid. So that means when we go through the next iteration, if it's not an adjacent bit of land there, then we'll increment the next number of islands. So most of the work's going to be in this traverse land here, and it's simply a depth first search. So I mean, depth first search and breadth first search, they're pretty much used for like all of these graph and tree questions. So usually it's just some sort of variation of something like that. So I'm going to have a function here, and I'm going to separate it out just to sort of make things a little clearer here. So I'm going to call this traverse land. So we know grid is an array of arrays of strings. I'm not really sure why they don't just use numbers, but I is going to be a number for the row, and j is going to be a number for the column. And basically what we want to do is we could say if the cell that we're on for the row and the column, if that's going to be, well, let's say if that's not equal to 1, if it's not equal to 1, there's no reason to traverse because it must be a 0, right? So, you know, there's no real, we can't mark water as marked land. So we'll just go to the next iteration in that case there. So we can just simply return out there like that. So this whole function here is just mutating the grid. And then that way, when you get to the next iteration, it'll be able to correctly increment the number of islands. So basically, if it is a bit of land though, we want to mark it as traversed. So we can do that. We can just say, well, that grid there, that position there, that particular cell, we're going to just use 2. 2 is completely arbitrary. You know, you could put whatever there, but I think if you have a string, it's going to take too much data up. So, I mean, we've got 0, we've got 1. Let's just use 2 here. So basically, we need some sort of way to check all of the horizontal and vertical positions. And this is going to be relative to the particular I or j value that you're on. So I think we should just create like an array of arrays, which will loop through, which is all the adjacent positions. So I'm going to have this variable here, adjacent positions, and you could probably make a type for this, but it's pretty simple. Basically what we're thinking here is, let's just say, you know, we're on the second row, on the second column. If we want to check one to the left of that, or one to the right of that, we want to take the I value that we're on and either subtract 1 or add 1. So that way we can check the cells to the left and to the right. So let's just go ahead and have those options there. And then likewise, if you want to check the cell directly above it and directly below it, we can just have 0 for the X position, and then we can either add 1 or subtract 1 from that. So this is sort of like a relative coordinate positioning for the adjacent positions. So basically what we can do here is we can make use of that now. So we can just have this for loop, and we can let something of adjacent positions. So adjacent positions is an array of arrays. So we can use array destructuring for the subarrays. And since we've got adjacent position, AP, we want to get the X value of that and then the Y value of that. So I'm just going to say APX, APY. So in this loop here, what we want to do is essentially we want to determine firstly if the position is valid, because you could be in the top left corner, let's say. So there's going to be no, like if you're in the position 0, 0, there's no position -1, 0, and there's no position 0, -1, you know, because, you know, you got that boundary. So we just need to check that boundary there. But basically, these are relative positions. So we're sort of looping through the rows and the columns, and we need to work out the cells adjacent to it, that particular cell that we're on. So we got this for loop. We're doing this for each of the adjacent positions. So to get the particular X and Y, and this is going to happen 4 times, we just take the I position that we're on, and then we can plus APX to plus on 1 or plus on -1. And then we can take the vertical positioning that we're on for the particular index, and then just add on APY. And that's the 4 adjacent cells in the horizontal and vertical direction for each iteration of the loop. So basically we want to be able to determine if they're valid or not. So we can say here, is X valid, or is valid X? And essentially X, it needs to be greater than or equal to 0, so it's not outside the boundary. But also X needs to be less than the length of the grid, so it's not on the far right side either. And likewise, I might just copy this down here, is a valid Y. So obviously Y needs to be greater than or equal to 0. So it's not, you know, above the 0th row there or whatever. And then, you know, the grid length, actually, this is the column. So this will need to be a 0 here. So that 0, you know, the number of grids, because it could be a 0, n by n, which isn't necessarily square, length there. And then all we need to do is we just need to say, well, if it's valid in the X direction and it's valid in the Y direction, but also if the grid in the particular adjacent cell that we're looking for, if that is equal to 1, then we need to continue to traverse the land. So this is where the depth first search part comes into play. Then we can just pass in grid here, X and Y. So just to sort of recap that, we have a, we're going to need to return the number of islands after all of that. So for each particular cell in our grid of the strings 1s and 0s, we're looping through, and essentially if the cell that we're on is the string number 1, we can add an island there, but then we can call this recursive traverse land function, which is depth first search, and essentially for all of the adjacent cells in the horizontal and vertical directions, You know, we can say we need to tell it that it's marks. We can add twos, and they'll continue to do that, and they'll continue to spread out um, until you're either out of bounds or you reach zeros. And then when that's the case, the grid will be mutated. So let's say the next land was a 1, or they would all be 2s now, unless it's water, which will be 0. Which, in which case, you've got that island sorted. And then if there's that boundaries of zeros there, separating it, and it goes to the next group of 1s, you can reuse this depth first search traverse land sub-algorithm, and apply that, and then you'll get your total number of lands there. So let's go ahead and just submit this code here. And we see that beats 95%, so that's pretty good.